Good morning, all. We'll be starting the session shortly. So we'll be starting the session shortly. Dear students, good morning. I can see that many of you are still joining. Okay, so we'll just wait for a couple of minutes, 2-3 minutes, and then we'll start. Okay, good morning, everybody. It's 10 a.m. and very warm welcome to the today's session, this webinar. So I would like to welcome Professor Matthew Jenkins. And before we start, I would like to a couple of minutes for his introduction, and we thank him for he has given us the time to take this session and share his knowledge with each one of us today. So as I go ahead, Professor Matthew is working as an assistant professor of supply chain management at East Tennessee State University. Dr. Jenkins received his Bachelor of Science in Logistics and Transportation, Master of Business Administration, and PhD in Supply Chain Management from the University of Tennessee. Dr. Jenkins' primary research interests concern supply chain resource orchestration, cross functional relationships, supply chain risk, and disruptive events. He has published articles in the Journal of Supply Chain Management, Journal of Business Logistics, Journal of Organization Behavior. He primarily teaches courses related to logistics management, strategic sourcing, international distribution, operations management, and supply chain optimization. And prior to entering academia, Dr. Jenkins' professional career involved working at the Oak Ridge National Laboratory, Department of Energy, managing database systems, Pfizer Incorporated, where he led the development of business intelligence systems for North American logistics, and Siemens Medical Solutions, where he led the international supply chain management operations for the PetNet Solution Strategic Business Unit. So, very warm welcome, dear Professor Matt.
So, sir, has Dr. Matt
Yeah,
joined?
Dr. Matt has joined. Dr. Matt, no problem. I mean, if there is related to video, no issues. I mean, we can continue with the audio. That is perfectly fine with us. No problem at all. Yeah. So if you can unmute yourself, can just maybe have a look. Yeah.
Good morning, sir. Good morning, ma'am.
Good morning.
Morning. It is not allowing me to unmute. Sir, I think maybe you can try and unmute Dr. Matt.
Or in case you want to maybe log in again once again, because the permissions. Yeah, sure. Okay, no problem. Thank you. So students, please wait for a couple of minutes. The speaker is logging again. I think there is some problem at his end. So we will continue the session in say 2-3 minutes. Yeah.
Sure, sir.
Okay. And as long during the session, please keep your mic muted, yourself muted. Only towards the end, in case you would have any questions, then we will inform you.
Hello, can you hear me now?
Yeah, loud and clear, Professor Matt. How are you? We can hear you, and
Good,
we
how
can
are
see
you?
you as well. Yeah, great.
I apologize,
Yes,
Ed. I
yes, sure,
apologize, everybody on the call.
sure. Thank you so much. We can see
Thank
you
you.
well and clear. Yeah, sure. Thank you.
So I'm going to attempt to share my screen.
Sure. All right. Thank you.
Good morning, Professor Matthews. This is Dr. Parul.
Good morning. How are you?
Absolutely fine. How about you? Our
I'm doing
students and
well.
our faculties are all very excited to hear from you today.
I appreciate that. Thank you. Can everybody see my screen okay?
Yes, we can all see.
Okay, great. Yes, I apologize for the slow startup. I'm not used to this platform. We're used to using Zoom, so I apologize. It took me a little bit to figure out, but I appreciate everybody hanging in there for me, and also I appreciate everybody attending this presentation. And what I hope to do tonight is just go through a little bit about what I know and what I've discovered about supply chain 4.0 and in particular digitization of supply chains and supply chain technology to really kind of give everybody an insight into what's going to change about how we manage and how we think about supply chain going forward into the future. And I apologize if I'm a little slow. It's 11:30 at night here tonight, so it's a little late. So if I'm a little slow, I apologize.
चलो दो
Dr. Matthew, I think you have muted yourself.
Yes, can you hear me?
Yeah, loud and clear.
Okay.
And Dr.
I'm
Matthew wanted
trying
to
to
inform
get.
that Dr. Parul is the Dean for Department of Management and Commerce at Manav Rachna University. So the lady you just spoke to.
Okay, nice to meet you.
Thank you. Thank you.
Same here. Same here.
And I'm trying to, let's see if we can do this a different way. I'm trying to advance my slides and it's not advancing for some reason. So let me try something different here.
Actually, when you click on present now, you can share the screen. And so whatever is like to say a tab or a presentation, if you have opened up, then we all will be able to see that. So just you can click on present now, that icon, and I hope that should work fine. Yeah.
Yes, again, I apologize. It's telling me I need to grant permissions to share the screen. Hmm. Okay. For some reason, it's not allowing me to share my screen. I don't know if my computer is stopping it from happening.
Okay, so can you try it once more?
Yeah, it's still saying can't share your screen. And I apologize. Let me log off and log in. We'll try this one more time. If this doesn't work, I'll just give the presentation verbally.
Okay, so also what I can do is, Professor, I can run the presentation for you from here. So if you can mail me the presentation, maybe I can open it up here. And as we proceed with the slides, because now you are the co-host also, we can work out that way also. Yeah. So the presentation which you have made, at least the students and will be able to share it, right? Yeah.
Okay. I'll log off and then log back on, and I'll send you the presentation at the same time.
Sure. Thank you.
Subodh sir, maybe you'll have to, like everybody can present here, right?
But I actually made him the co-host. I don't know why he was not having the
I think
permission.
there are options, your entire window, entire screen, a window, or tab, maybe he's getting confused there.
Maybe. Yes. I will open the presentation here if I get it, no problem. We can do it that way.
Okay, so I sent the presentation, and I'm going to try this one more time.
Okay, okay.
See if I can allow me to do this.
So, Dr. Subodh, so one more thing, I mean, you would know already is that Professor Matthew might keep the presentation open on his screen. Then it will be visible. Then he can share the tab. If it's not open and he's just sharing it from the desktop, then it doesn't happen.
Yes, I think this is what I'm going to do is just
Yeah,
share it this way instead of
we
trying to
can
run
see
it
it
as a
here.
PowerPoint. I think that's
That's
what
how it
maybe
is.
caused the issue.
Okay.
So again, I apologize to everybody for the technical difficulties. I appreciate everybody working with me this morning. So a quick brief introduction of myself, and I think we already covered some of this, so I appreciate the great introduction and information shared with the people on this call. But really quick is my name is Matthew Jenkins. I'm an assistant professor of supply chain management at East Tennessee State University. I teach classes primarily in supply chain optimization and supply chain strategy. And my research is in supply chain technology as well as looking at supply chain development, implementation, and bottom of the pyramid markets. My background is I have a computer or a computer science background. I worked at the Oak Ridge National Laboratory managing databases and information systems and developing statistical programs for research, looking at heavy metal contamination in soil. I worked at Cardinal Health as a a pharmaceutical distribution supervisor in a warehouse operation. And I also worked at Pfizer Pharmaceuticals as a lead analyst for North American Logistics Business Analytics. And there I did report development, analytics development, and predictive analytics. I worked for a time at Siemens Medical, where I manage a global supply chain for manufacturing and distribution of radioactive pharmaceuticals for use in positron emitting tomography or PET scanning for detection of cancer. After that, I decided to go back to school and get my PhD at the University of Tennessee in Knoxville, Tennessee. Completed that in 2017, and then I went to work at Georgia Southern University, which is in South Georgia, close to Savannah, so close near to the coast, and worked there for 2 years, and then took an opportunity to come back home. I'm from Tennessee, and this is where my family is, so took an opportunity to come back to Tennessee and went to work for East Tennessee State University as a assistant professor now. To give you an idea of where East Tennessee State University is, here's a map of the United States. You can see we're almost smack dab in the middle of the southeastern United States, just west of North Carolina and north of Georgia. So if you can see that, where that dot is. Here's a picture of campus. It's kind of a grainy picture. It's kind of blurry, but it's a beautiful campus. We're surrounded by mountains. It's located in the Appalachian Mountain region of the southeastern United States. It's a very rural area around us. Very beautiful, lots of wildlife, and a very nice campus. So today I'm going to talk a little bit about Industry 4.0, and we're going to talk about how that relates to Supply Chain 4.0. And then talk a little bit about digitization of the supply chain and what that means for us as academics and practitioners. So the last few decades of the 20th century saw a lot of change in supply chain. Really the industrial environment and the economy itself. We had steady economic growth in many countries, and this was especially true following the devastation of World War II across Europe and many parts of the world, as we've had kind of an unprecedented period of economic growth in most parts of the world, and that stretches to even the emerging markets around the world have experienced tremendous increases in personal income and wealth and growth and economic opportunity. We've spent the last several decades in looking and finding new sources of supply all around the world. This could be developing new manufacturers in Africa, as well as looking for sourcing raw materials in Argentina, South America, and really some places that us as Western supply chain practitioners, we had never really thought of going and sourcing materials or building factories. And really, we've expanded across the globe our manufacturing, our supply chain operations. And it really accelerated over the last few decades of the 20th century. A lot of this has driven lower input costs across a diverse range of industries. This has been accomplished in a couple different ways. The first is going to what we call low cost countries, which are countries that have a lower labor rate than other nations. And you can go to those nations or countries and obtain manufactured goods cheaper than you can make, for instance, in Western Europe or the United States. And China is a prime example of that. What's happened in China over the course of the last 30 or 40 years. But what's interesting about this phenomenon is it seems to be shifting, back to moving manufacturing closer to local markets. So if your market is in India, chances are we're now building manufacturing centers in India to support the Indian markets, as opposed to manufacturing in Vietnam and exporting and importing it. So we're seeing an explosion of what we call reshoring of manufacturing operations back to the home market country. The concept of supply chain really took off. It developed in truly the first time it was defined as an end-to-end phenomenon. Now, what that means is traditionally what we've thought of supply chain as obtaining supplies that you need to manufacture a product. And then we had logistics, which was the distribution of the management of that product and delivery of the product to the customers. And what supply chain management is a combination of all those things, and looking at the end-to-end flow of materials and information all the way from the ultimate source, or that first supplier where you're getting your raw materials, all the way to the manufacturer, to the distributor, all the way to the retailer, and to the customer. The end-to-end pipeline that the products and the materials traverse to get to the consumer's hands. That whole concept of looking at the entire system really came about over the course of the last few decades, and this has implications for some of this new technology, because a lot of it has to do with supporting that connectivity that we're seeing around the world now. So also technological and management tools and techniques have come about, some very swiftly over the course of the last 20 or 30 years. Just-in-time management principles have been widely implemented across most industries now. Just-in-time is what it says it is. It's only receiving the inventory that you need for production at the very moment that you're going to consume it in your manufacturing process, as opposed to holding many weeks or months of raw materials in your manufacturing warehouse in anticipation of manufacturing or production. You only receive it on maybe the day or the week that you actually need it. It's just in time, as the term says. Now, information technology transformed our ability to manage complex supply and demand networks, and this went hand in hand with going to more global networks, where we're offshoring manufacturing, offshoring, in a lot of cases, even some of the logistics services that we use, like freight forwarding services and 3PLs or third-party logistics services as well. There's a third industrial revolution that just finished, and we're entering the fourth industrial revolution. The third industrial revolution was driven by the development of the computer and development of the internet. So Apple computers, the smartphones, the iPads, all of these were part of this third industrial revolution. But it had two predecessors. It had a first industrial revolution and a second industrial revolution. The first industrial revolution was using steam and water power to increase the efficiency of manufacturing. The second industrial revolution was the use of electricity to enable mass production and the development of the modern factory. However, moving into the fourth industrial revolution, which originated from government-backed initiative in Germany, is the difference here is it's an umbrella term used for a automation of tasks, use of artificial intelligence, and development of connectivity through technology such as the Internet of Things. Now we'll get into what some of these things are. But the promise of the fourth industrial revolution, or what we call Industry 4.0, is to be able to deliver greater customer value through customized solutions using fewer resources. And what that means is transitioning from what the first industrial revolution did was economies of scale, transitioning from economies of scale to now we're in the fourth industrial revolution, where we're moving to economies of scope. Okay, so next slide. So the first industrial revolution, just some pictures so you can kind of picture it in your mind what this period looked like. And it was really the application of steam power to productive processes, mechanizing things that we typically did by hand or in small batches or at home and in small quantities. In really mechanizing those processes using steam power to create kind of the first semi-mass production. The second industrial revolution, you go to the next slide. So the second industrial revolution was using electrical power to further refine that idea of mass production. And a good example of this is the assembly line for the Ford Model T, which could not have happened without the advent of electricity and the technology and mechanization that it provided. A good example for us in East Tennessee, here where we live, is we have something called the Tennessee Valley Authority, which is TVA. Up until about the 1940s, 1950s, most of what we call the Tennessee Valley did not have electricity, and the U.S. government came in and used broad initiatives and built hydroelectric power plants all over this region to electrify it, which then brought industry and brought mass production to this region and really increased the economic outcome for a lot of people living here. So next is the third industrial revolution. So the third industrial revolution is the one that we just exited. Again, a good example of this is Apple computers. In really their story, starting out in Silicon Valley, starting out in a garage with that's a picture of Steve Wozniak and Steve Jobs there on the upper right. You're working with the first, I think that's an Apple II, not an Apple I, that's an Apple II. The first one that really took off for Apple computers. But the idea of the personal computer that really revolutionized how we interact with the environment and with each other, and how businesses manage themselves. In going all the way from those first computers and first personal computers and business computers to the usage of satellites, which you see there on the upper left, to provide access to the internet for all of us. And then also, some automation technology with robotics, and you see that on the bottom. And so this is kind of the era that we're leaving right now as we enter into this fourth industrial revolution, which is the next slide. So the fourth industrial revolution is a combination of all the things that we're already used to seeing, our tablets and everything else, but some things on top of that. A big change is that it's not just our phones or computers are hooked up to the internet. It's everything that we buy, everything that we own, and many things that we use now have the ability to be hooked up to the internet and provide data back and forth. A good example of this would be Alexa, and any type of Alexa-enabled device, which is produced by Amazon, is constantly collecting data and constantly providing that back up to the cloud, to Amazon. But the idea is that the world consists of a network of interconnected devices that are always communicating with each other and sharing data. And then this data can be used to automate processes that we're used to be doing either in person or by hand. A big change we're going to see is we're going to see a lot more artificial intelligence as it applies to what we call the cyber physical world, or essentially robots that are smart and can follow commands and do things for us. But we're going to see a lot more of this interconnectivity. Okay, next slide. So the progression through the different cycles has been, so the first is mechanization with the steam power. So that was Industry 1.0 of the late 18th to the early 19th century. So you had industrial cities, the steam engine and mechanical production. And then you had Industry 2.0, which is the late 19th and mid 20th century with mass production, with industrial regions, with electricity and division of labor. And then you had the second half of the 20th century, which was Industry 3.0, which dealt with a lot with automation and computers and computing technology. And then we're moving into Industry 4.0 in the early 21st century, and looking at global value chains and something called cyber physical systems, which you can think of cyber physical systems as a collection of autonomous mechanisms or controllers that are making decisions on their own to do things like turn the heat off and on in your house, or to speed a train up on electric rails, to speed it up or to slow it down, or even in cars, the driverless cars or autonomous cars, where you have the key to it is you have no human intervention in the process, which is something completely different to how we've been living in the past. Okay, next slide. Okay, some principles for understanding Industry 4.0. The first is interoperability, which is enabling communication through Internet of Things between people, machines, and cyber physical systems. So these things essentially have to be able to communicate. So you have to be able to communicate between your Alexa-enabled devices, your cell phone, maybe the washing machine you have in your house, or your dishwasher is connected to the internet. But these things have to be able to connect and be able to talk to each other, and do so continuously. Virtualization, the physical processes are monitored through sensors and other means, and the data generated can be used to create virtual models of that system. So every system, every physical system we can think of, whether it's a system that controls the water flow through locks and dams in a river to provide water transport for transporting goods, or whether it's a water treatment plant that is used to clean water coming out of a city. There are physical processes that continuously go on in these plants that are monitored through these sensors that then can generate this data and can communicate up to the cloud, where you can look at virtual models of the system of what's going on in that system, down to even what the flow rate is along certain locks and certain dams in a river, perhaps at any point in time, that you can create virtual systems. Decentralization is another principle of Industry 4.0. We're going to see a lot more decentralization. Cyber physical systems are capable of making decisions autonomously with reporting only on an exception basis. So a good way to visualize this is to think of autonomous driving cars or trucks, where these cyber physical trucks, these machines, can make their own decisions about when to change lanes, how to change lanes, are they in the correct lane, when to stop, how to stop, when to speed up, when to slow down, is there a pedestrian crossing the road? All those are split-second decisions that these machines are making every day, and the only time a human would be involved is if there's an exception to the process somewhere along the road. So this really decentralizes that decision-making process. So the next is real-time capability. Through sensors, barcodes, RFIDs, or radio frequency identification tabs, and other means, performance of the system can be constantly monitored and progress tracked. So this goes beyond just understanding the speed of a conveyor belt in a distribution center. If you're managing a fleet of trucks that are on the road today, let's say you have 1,000 trucks, and then a red light blinks on your screen, and let's say you have a screen where you're monitoring all these things, and a red light blinks, and it tells you that one truck in that fleet of 1,000 trucks is beginning to overheat and it needs to be serviced. And it's a warning that if it's not fixed, then it will break down the next day. That's a real-time monitoring through sensors that that even a truck overheating can be transmitted back to some type of central command and control location, where somebody looking at that can then call and make sure that truck gets maintenance the next day. Service orientation through cloud-based computing and other means and functions provided by cyber physical systems can be made available to others as a service. So organizations not just investing in these technologies for their own manufacturing, but also providing access to them to other companies as a service. Modular systems are able to rapidly adapt to changing requirements through a plug-and-play capability is the other one. Okay, next slide. Okay, supply chain 4.0, using the industry 4.0 principles that we just covered. So supply chain 4.0 is going to operate or operates within those principles. And what that means for us as practitioners is we need supply and demand networks that respond quick to changes in the environment. And the environment is changing quicker, faster than it has over many, many decades. Uncertainty and volatility will only increase over time, and that's uncertainty and volatility of not only demand and what consumers and customers are wanting and needing, but also of supply, of perhaps critical shortages of critical supplies, of energy shortages, other things. There's going to be a lot more uncertainty and volatility in the future that we haven't experienced. And COVID-19 and what's happened with the pandemic is a pretty extreme example, but it's an example of some of that uncertainty. And we're only going to be seeing more of that in the future as things move forward. So there is a need for quick response in our supply and demand networks, and to be able to use that technology and these principles that govern Industry 4.0 to make sure that we can use our supply chains to a competitive advantage, that we can rebound and we can recover from any shocks to the supply or any disruptions in our purchasing process. Or any volatility in customer consumer demand. So supply chain 4.0 is really just Industry 4.0 principles they're incorporated into the practice of supply chain management, and there's some specific technological ways that we do that. Okay, next slide. Okay, there is a new reality for us supply chain management practitioners. There's a fundamental shift in the power of demand from a homogeneous market to a heterogeneous market, which essentially means that it's the creation of one or a batch size of one. Where it used to be we manufacture one product and we captured economies of scale by manufacturing the same thing over and over and over again. Now we're customizing products for individual customers, and that's really going to change things. Prime example is Henry Ford and the Model T. The famous quote is, Henry Ford said, "You can have the Model T, you can have it in any color that you want as long as it's black." However, we've gone from that to now we have the Nike Air Zoom Pegasus, which is a new shoe by Nike, which provides customers multiple options that you can choose from to really create a unique shoe, and you create your unique shoe online with the colors or the different prints that you want or the different color bottom or whatever it is, whatever that combination is, and you submit your order, and they manufacture that batch size of one. It's your personal shoe that you've helped co-create. You've helped design it. You've designed that shoe, and you're the only one who owns a shoe like that. And Nike is doing that right now, and that is the new way of doing things, and that's the challenge. Traditional supply chain management thinking has been driven by economies of scale. It's the greater the volume, the lower the unit cost, which requires larger batch sizes and the ability to maximize the utilization of your capacity, whether it's your manufacturing facilities, your trucks, your trailers, but it's the capacity of your assets to maximize that to gain those economies of scale. We're shifting from that to tomorrow's supply chain management thinking, or I would argue reading there today, is more driven by economies of scope, offering a greater variety, but doing so with the same resources. And that's the key to it, is being able to offer these unique shoes and unique experiences to customers, but doing it with the same amount of resources, not more resources or more cost. And the promise is that Supply Chain 4.0, the technology, the extension of Industry 4.0, is going to be what enables us to do this batch size of one, this whole strategy. Okay, next slide. And so here's an example of that Nike Air Zoom Pegasus shoe that I was discussing. You can tell by looking at this. This is a very unique design. Whoever designed the shoe, I doubt you would find another one exactly like this. But you can just see just how personalized it could be. So you could make your shoe orange or red or whatever you wanted to do with it, and Nike will manufacture it based on your specifications. Okay, next slide. So now we'll get into specific technology that supports Supply Chain 4.0. So we already talked about the Internet of Things. And again, the Internet of Things are all the mundane day-to-day things that we use that are connected to the Internet now. And your refrigerator, your TV, your obviously our smartphones, but your washing machine, your dishwasher, anything like that, a lot of it is now connected to the Internet and providing data. Artificial intelligence is a big part of Supply Chain 4.0. Robotics, blockchain, big data analytics, virtual reality, drones, 3D printing, autonomous vehicles. The key to it is all this technology is disruptive individually. But what makes Supply Chain 4.0 is connecting all these technologies together for major disruptions in how we do things in supply chain management. Okay, next slide. Okay, here's a couple examples, autonomous vehicles and drone delivery. So there on the left, I believe that's a Volvo autonomous truck, picking up a container at the container yard and and going to make a delivery to the final customer. So this is the future. This is what the future of port operations is going to look like. It's going to be automated. It's going to be computerized. It's going to be robotic. And we'll have sensors in the truck, on the containers, and all the machines that are used to move the containers. And all of that will be automated, and there won't be any human intervention in the process. This is what the future is going to look like. And on the right, you have here, and I don't know if perhaps y'all are doing this in India as well, but Amazon Prime has started. That's one of our major retailers, or e-commerce retailers, have started making drone deliveries here in the United States, in places like Florida and California. And that's what you're seeing on the right. And again, a lot of these systems are automated. Okay, next slide. And here's another example of, and this is where the connectivity of really the Internet of Things and all these sensors, it's feeding data into these enormous systems, and then with that data, companies are creating what are called supply chain control towers, which is really, when you think of a control tower, you think of airports, you think of airplanes. It works the same way. It's a personalized dashboard of data that gives you real-time tracking on key metrics in your supply chain and events across the supply chain. So something like a truck overheating in some part of the country that you need to take care of, maybe that's on your personalized dashboard. But the key to it is that these supply chain control towers it's taking these large amounts of data and putting it together in such a way that you as an individual person can consume it to then make decisions. But it's smart enough to know what are the important things that you need to see, and that's the difference. Is you're only looking at the things that you really need to see, and what the system is defining as important. Okay, next slide. So what are the outcomes of all this technology of Industry 4.0, Supply Chain 4.0? Well, you have automated smart manufacturing, warehousing, and logistics, which will lead to mass customization. So think of that Nike shoe, but think of all the different products that you could buy in the store and customize to your liking. The promise also is to lower costs. Again, we want to do this mass customization, but we don't want to use any more resources than we're using. In fact, we want to use less resources and become more sustainable, and that should lower costs. Lower time to market for new product and new design. Better asset management, so better management of all the assets that the company owns. Better sales or increased sales. And digitize a blockchain integrated supply chain system helps in streamlining these following areas as well. Selection of supplier and supplier-enabled innovation, routing, dispatching, and maintenance of transportation networks and machines, and detection and rectification of points of failure, inefficiencies that increase costs, but doing all that in real time. Okay, next slide. Okay, more supply chain 4.0 outcomes. So again, these are the good things that we expect to happen. End-to-end transparency. So no more islands of data where only one large company has enough data to efficiently process its forecasts and to manage its manufacturing. The idea of end-to-end transparency is all partners within the supply chain, whether you're a third-tier supplier, second-tier supplier, or the large manufacturer, or a large retailer, or maybe a small retailer, everybody has equitable access to data on consumer sales and transportation transactions and inventory positions and inventory quantities and different warehouses. All that information is shared. A dynamically adjustable and synchronized network, so a network that can adjust to shocks in the supply chain. um, the implementation of blockchain or a global transaction management system that can record and verify events and stop things like fraud or fraudulent materials from entering the supply chain. Real-time data and predictive analytics, control towers, real-time performance management, real-time process management, and instantaneous supply and demand planning. Okay, next slide. Okay, all this is great, but there are some pretty sizable skills that will be needed to manage all of these different technologies. Strategic and big thinking. So that these are large concepts that require managers and workers to think beyond the four walls of their own company or their own firm or even their own industry, and look at supply chain as not a chain but as a network of companies that are interrelated and are many tiers deep. And strategic thinking in terms of long-term thinking into the future, and not just a 5-year horizon, but a 10-year horizon, 15-year horizon. Technological expertise. It's going to raise the bar or raise the need for more technological expertise to manage and to understand these systems. So even though we're taking human elements out of decision making, somebody still has to manage the decision makers and understand how to implement that technology and maintain it. Change leadership. These are big changes, and they're going to change how employees work in the warehouse or don't work in the warehouse. What are we going to do with all the truck drivers once we automate truck driving? What's going to happen there? There's a lot of change that is threatening to a lot of people. And so change leadership is going to be absolutely crucial in making these changes. End-to-end expertise, control tower leadership. Control tower leadership, definitely from within a company, but also across organizations, is who is going to set standards. If you're going to have a control tower for an entire supply chain, which may consist of 20 different companies, who's going to set the standards for the control tower that the entire supply chain uses, or that entire supply chain network? How are those metrics going to be measured and shared? Where is the data going to come from? How are we going to make sure that the data are accurate? Control tower leadership is going to be important. Data analytics skills, risk management expertise, and best practices knowledge will also be very important. Okay, next slide. Okay, so are we ready? Is our supply chain ready? And this is where I struggle with it. Is it? And maybe it's my age, but a lot of these technologies I've seen them come about, and some of these technologies have been around for a while. So RFID, we've been talking about that for probably a better part of 30 years. We've been talking about something similar to the blockchain. I know I worked in the pharmaceutical industry. We were talking about something similar to blockchain pharmaceutical industry back in 2003 or 2004 to stop counterfeiting. But it's confusing because there's so many technologies, and you're asking us to integrate all of these things together to fundamentally change how we function and how we manage and how we operate. It's very confusing. And are we ready? Is our supply chain ready? For the supply chain 4.0 for these technologies? I would say no. I would say I don't think we're ready as practitioners, as academics. I think we're just scratching the surface. Next slide. And to me, I think one of the biggest issues we're going to face is not the technology itself, but the human technological interface that is going to change, and it's going to be very disruptive to how employees work and how they see work and the things that they do day to day. And I think what is going to either either help us succeed or slow us down, and we may fail in some cases, are how ready are the people to accept, and how ready are people to do they have the proper skills to operate in this new technological environment. And to that end, I'm going to share with you all just a little slice of research that we've been working on in partnership with the University of Tennessee, where we're looking at, do companies really understand what the supply chain 4.0, this digitization of supply chain, all this technology, what does it really mean? And are companies ready to implement this? And they may sit in their executive boardrooms with upper management and have conversations at the C level, the CEO and CFO, and think that they're ready. But when you peel away the layers of the organization and you get to employees and supervisors and first line managers and middle management, that's where you're going to see the issue, is transitioning from what we're doing now to what needs to be done. So really, this is just a little slice of some research that we're working on. And here what we looked at is we looked at readiness of organizations to implement supply chain 4.0 technologies. Okay, next slide. So we used a survey methodology to understand and benchmark organizations' workforce or change readiness, and also identify the enablers and impediments to what we're calling digital transformation, i.e. supply chain 4.0. What are the things that are going to help organizations, and what are things that are going to impede organizations implementing these things, and how ready are organizations? For this, we work with 3 partner companies, rather large multinational corporations that partnered with us for the survey. And then we did a cross-industry comparison using a panel data survey with Amazon's MTurk, which essentially you pay people to take the survey for you. And across 6 samples of responding employees, we assessed the workforce's capacity and readiness for the digitalization change. Next slide. Okay, change readiness was measured as change acceptance, change aspirations, and change fatigue. Those are the 3 change readiness components. Change acceptance is the degree to which employees accept and support the change. And keep in mind, this is change specifically related to digitization of supply chain activities, or supply chain 4.0. Change aspirations, the degree to which employees believe change will be successful. So if we implement this digitization change, will it be successful? Will our effort be worth it? And then change fatigue is the degree to which employee resources have been depleted by a change or a previous change. So one of the things that we're finding out in research that that could be a big barrier to all this is employees are tired. They've been through many changes in recent years, and they're fatigued, and it could be that fatigue that could be one of the big things that holds us back from being able to implement some of these technologies fairly quickly. Next slide. And the change readiness. So this is on a scale of 5. So we found that there was good change acceptance and change aspirations. So people really believe they're accepting of this digitization technology, and they have aspirations, or they believe that their effort will be worth it. However, if you look at the change fatigue, and this is a reverse scale, so actually a low number is bad. It's a 2.5. People are fatigued. The feeling is that we've changed too many things about their jobs and how they do things, and they've gone through too many change initiatives too soon, and so fatigue is a real big issue in the workforce. Next slide. So what are some of the impediments to digitization or supply chain 4.0? So we know that our workforce is fatigued, but what are some other things that according to the respondents, that are going to slow down the implementation of these things? And what's interesting is if you look at the top four, it's competing organizational priorities, insufficient internal digital skills, cultural resistance to change, and lack of organizational strategy deploying a digital vision. 3 out of the 4 of those have nothing to do with, are we ready from a training standpoint? It's we have competing organization priorities, and that is by far the top one. Is that we have other things than the organization that management is telling us is just as important, if not more important, that are detracting from ability to do things like supply chain 4.0 technology. And also the cultural resistance to change is a big one that has come up, and a lot of that may be related to the fatigue that people are feeling with all these changes, and the lack of organizational strategy deploying a digital vision. So next slide. So the findings were, despite the presence of well-planned digital transformation efforts and change readiness within the workforce leadership and resource constraints can reduce or even mitigate the benefits of supply chain 4.0 transformation efforts. Regarding enablers of digital transformation, cohesive and well-articulated strategy is an important condition. So if a company wants to be successful implementing these technologies, one of the first things that they need to have is a well-articulated strategy for doing so. And organizations generally believe that digitization will positively impact their work eventually. Next slide. Respondents generally indicated impediments that would substantially derail digitization initiatives. And the top 4 were competing organizational priorities, insufficient internal digital skills, cultural resistance to change, and lack of organizational strategy deploying a digital vision. And again, what's interesting is 3 out of the 4 of those are related to people and people's attitudes, as opposed to having the proper technology or even the proper training for the technology. Okay, next slide. Okay, so that's it for the presentation. I'd like to open up for any questions.
Okay, so students, any questions you have, feel free to ask. Professor Matt is here, all sharing the knowledge here. I think all these sessions. Yes, anybody who would like to ask can unmute and ask the question. In case you want to type the question on the chat window, you can type it there.
No, sir, thank you.
Okay.
Sir, I have a question.
Yes, Aksham, go ahead.
Mr. Matthew, by your presentation, I can surmise that the only limitation in implementation of digitization is human element. In how well will the workforce cope with the changes, and is the only necessary skill in future is computer related skills or programming related skills and all that?
Yes, to answer your question, I think I don't know if it's the only thing that will impede it. I think it may be one of the largest factor, one of the biggest factors is the human element. And if we think about, we take the case of a truck driver. A truck driver is used to doing his or her job in a certain specific way. They're used to being autonomous and being able to make decisions on their own. And that autonomy is being taken away from them even before autonomous driving. With GPS and tracking and all that, they're being told where to turn, to speed up, to slow down. And then you take away their entire job with autonomous vehicles. There's going to be some resistance to that. Even looking at something like the factory floor and people working in the factory, you're going to be changing how they interact with the manufacturing line, or if they interact at all. And so there will be a resistance to that change at the individual worker level. But even more so, I think to make these technologies work, you have to have a lot of trust between organizations to be able to share data and to share technology across organizational boundaries. Especially when you talk about doing it internationally, companies are worried about opening themselves up to cyber attacks and other things. And I think that fear or lack of trust could be one of the big issues with being able to implement this and for this technology to reach its promise. So I think, and you alluded to programming skills and hard skills, and I do think there is going to be a need for more of that, because instead of managing processes, I think we'll become more systems managers instead of process managers, if that makes sense. And that's going to require a different skill set for people. But I think even with that, I think that these human relational issues are going to be the thing that's going to be difficult to get around or to solve.
Okay,
Okay.
great. Thank you, Professor. Yes,
Dr.
Audrey.
This is Vandana. I'm the program coordinator for undergrad operation management program here. So I have a question that since we have seen for the past 2 years, there has been an unprecedented disruption global giants, say manufacturing giants. We have had once in a lifetime event of even Toyota shutting down its factory for 6 months because of the disruptions in supply chain. So, what is the role of digitalization in future to prevent such events?
I think it's so if I look at this from a global scale, I don't think that technology could have prevented, and I know this isn't what you're asking. I'm just thinking through this logically. It couldn't have prevented the pandemic from occurring. One could argue that if we had implemented some of these predictive analytic technologies, we could have had a better our response could have been better to the pandemic than when it started. But even without that, what's happening with the restart with the global economy and the restart, and I know a lot of what's happening here in the U.S. Has to do with, it's bottlenecks in the system that have been exposed through the pandemic, and it's issues that we know and have been going on for years. But I know in supply chain, we've been talking about the bottlenecks at the ports for 20 years, and that at some point, those bottlenecks at the ports are going to cause real issue with international trade. And it's not just in the U.S. It's a lot of different places around the world. And what's happened is, that issue is now here, is that these bottlenecks at the ports are causing us not to be able to import the product into the U.S. and we have massive issues right now with inflation. And I think it's true in a lot of parts of the world that the same thing is occurring. So I think this technology, if you apply it to a national or international transportation infrastructure level, could have foreseen some of these bottlenecks and some of these issues at that infrastructure level, and could have directed possibly national and international investments into increasing the capacity of these ports, or automating or increasing the level of automation at the ports, before something like this happened. And I think going forward, I know for us here that this may be a bit of a wake-up call. And what's interesting about in the U.S. is we have access to all this technology, but our ports on the West Coast, in LA and Long Beach and California, are using 40-year-old technology to unload these ships. We have not automated those ports, even though they're the busiest ports in the country. And a lot of the ports on the East Coast have been automated, but not the West Coast. And that's a lack of implementation of some of this technology. So I think if we learn our lesson, we automate and we invest in and we implement some of these technologies, you will become more flexible and we'll be able to flex and absorb some of these shocks in the future. Um, so I'd like to think with that agility that with this technology that we would be able to weather something like COVID, the pandemic, a lot better than we have.
Thank you.
Sir, I have one question, Mr. Matthew. So, how will we cope with the shortage of resources in the future and with the consequent reduction in employment as well as a consequence of digitization of supply chain?
I apologize. I couldn't hear the question.
I'm saying, how will we cope with the significant reduction in employment and resources in the future, considering if one's livelihood is threatened, it's probably um, met with resistance and could possibly disrupt social cohesion as well.
Yeah, that's going to be a secondary problem. I've thought about that. Is if I'm hearing the question correctly, is this technology is seems great and there's promise to it, but you're going to displace a large portion of the workforce implementing this. And so the question is, as a society, what do you do with those people or for those people? And I think your options, you do have a few options. You can retrain, but honestly, will there be as many working positions after automation as there are before? So will there be enough positions, managing the systems that people will be able to be able to find work even if when they're retrained? Yeah, I don't know the answer to that. I mean, the other thing that's been tossed around is, or idea that's been discussed is, after we reach some level of automation, is that when the idea of universal basic income, does that become the only viable option for a group of people to maintain social cohesion and allow people to be able to live? I don't know. I don't know. These are good questions.
Okay, so thank you. Anybody else who has a question I would like to ask? Okay, so I think that has been great. So Ms. Vandana, I request you to for a vote of thanks to Mr. Matthew.
Yeah. So, Dr. Matthew, on behalf of the faculty members and students of Department of Management and Commerce, Manav Rachna, I would like to thank you for such a erudite session. It was a pleasure to have you here. And Manav Rachna is in fact celebrating 25 years since inception. And your insightful session was a I would say feather in the cap in such a celebration. And I'm sure all the students have benefited immensely from this session and would implement the learnings that they have gathered from here in their future endeavors. And it was an honor to have you here. Thank you once again.
Thank you very much, and congratulations on 25 years. That's a very exciting accomplishment. But congratulations to everybody.
Thank
Thank
you,
you.
Professor Matt. Thank you so much.
Thank you
Thank
so
you,
much,
sir.
Professor Matthews. Thank you so
Thank you.
much, Professor Matthews. It was no doubt a wonderful learning session for not only for the students but also for the faculties, I believe. And I believe Dr. Pragati, my HOD, and on behalf of the entire faculties of the Department of Management, and on behalf of my senior functionaries, Vice Chancellor, my Chancellor, Dr. Prashant Bhalla, and Vice President, Dr. Amit Bhalla, and on behalf of my Vice Chancellor, Dr. I.K. Bhatt, I really
Ma'am, I have
thank
doubt.
you from the... Yes, I believe somebody was trying to say something.
No, ma'am, carry on. I think it was just by mistake.
Okay, that was by mistake. So we really thank you from the core of our heart. And I will give this opportunity now to my HOD, Dr. Pragati, to really talk about more collaborations, about how we, as a private university, you as a university there, how we can collaborate with respect to research and other exchanges the way we have done today. Over to you, Dr. Pragati.
Good morning, Professor Matthews, and my extreme thankfulness to you for being here at this hour of your day there and connecting with our students. And indeed, you had given some valuable insights on both the teaching and research dimensions in the field of supply chain. So as far as Manav Rachana goes, we are a part of a bigger banner, Manav Rachana Educational Institutions, and ours is a state-private university. And so in this 25th year, we are really working upon many things. And amongst the many endeavors is our focus to strengthen the International Faculty Connect program. And this is the reason why we have connected with you. And we would really want this association to stay long term. And so because we also happen to run a BBA Operations Management, this is a specialization program in the operations and supply chain area. And your insights today in this area must have been very useful for the students and the faculty. And it is in continuation with this that we would want to stay connected. We would further want to strengthen this association with your university, with you as a faculty there. And maybe we can work out something more better to be given to our students in this program. So anything you want to add on now, you can give me, or we'll connect over the email and convey our pointers to you.
Thank you very much. And I would be very interested in continuing the collaboration.
Right.
Seeing what opportunities there are for us to work together.
Yes, absolutely.
We have many students here that would really enjoy and would really benefit from interacting with you, and there's research as well, possible research collaboration opportunities. But no, this has been a wonderful experience. I apologize. I know I'm a little bit slow tonight. I'm tired.
No, so that's perfectly fine. You were completely on
No
the. Yeah.
But I appreciate everybody's time. Some very thoughtful questions, and this has been an honor speaking to you all, and I really do appreciate it.
Sure, sir. We'll connect further on the mail and how we can further strengthen this association. And thank you so much for being here, sir. Once again.
Thank you.
Thank you. Bye-bye.
Thank you, students, for joining. Thank you.
Thank you, ma'am. Thank you, sir.
Thank you.
Thank you, ma'am.